In this video we learn about the derivative function. That is, what's a derivative function and what's differentiation, as well as what we use those two things for. Now here we're given a graph in which we can see a straight line. And we can go further, and actually that line's equation is y equals to 2x minus 1. And now here comes a question. What's the gradient of that line? Well, it shouldn't take us too long to see that no matter where we go on this line, for instance, at this point or at that point, the gradient of the line is always the same. It's 2. And in fact, that's what makes a line straight. The fact that the gradient is constant, or always the same, is exactly what makes it a straight line. Now, on the other hand, if we were to look at another type of curve, say this one here, this curve has an equation, y equals to x cubed over 10 minus 7x over 10 minus 3/5. And again, we could be asked the question, what's the gradient? And once more, let's look at 2 points on this curve. Say, what's the gradient here? Or what's the gradient at that point there? Now, the difficulty we encounter here is the fact that, in this case, the gradient is always changing. Each time we move on to a different part of the curve, the gradient is different. And for that reason, we need something. We need to come up with a method to find the gradient of this curve at different points along its length. So the key thing there is the gradient changes as we move along the curve. In fact, the gradient is a function. It's a function of x. Depending on the value of x, the gradient of the curve is different. And now, that's exactly what a derivative is. A derivative function is just a gradient function of f of x. And we write the derivative f dash of x, or dy dx. Remember, I'll say that again. The gradient of f of x is given by the derivative of f of x. Let's go ahead and see how we could use the derivative. Here we're given another curve, and its equation is y equals to 0.15 x squared plus 1. That's the curve of the function f of x equals to 0.15 x squared plus 1. And we don't know how to do this yet. Don't worry, we'll learn soon. But the derivative function f dash of x is 0.3x. Now, that function gives us the gradient of the curve at any value of x. For instance, we may be asked, what's the gradient when x equals to 2? In other words, we're asking for the gradient on the curve at this point. Now, following what we said earlier on, all we would have to do is let x equal to 2 inside our derivative function. That's f dash of 2. And that's equal to 0.3 times 2, which is 0.6. And that's it. The gradient of the curve at that point is 0.6. And what's very useful with the derivative, or the derivative function, is the fact that we can do this at any point along the curve. Say, for instance, we're asked to find the gradient when x equals to 4. That would be this point here. Well, again, the method would be the same. We would use the derivative function again and just replace x by 4. That's f dash of 4. And that would equal to 0.3 times 4, which is equal to 1.2. So the gradient of the curve at that point would be 1.2. Now, the process via which we find the derivative is known as differentiation. And the derivative is a function that gives us the gradient of a curve at any point along its length. I hope that helps.